Hello Year 12. Now we're on to the final section of our Carbonyls module, and today we're going to be looking at how we distinguish between aldehydes and ketones with easy chemical tests. Okay, so the spec points we're covering. You'll notice they mostly focus on the use of Tollen's reagent for detecting aldehydes and ketones. However, the other ones we're looking at could come up as a stretch or challenge question where they're trying to get you to apply ideas in context, so it's good to know them. So, the only real difference between aldehydes and ketones is that aldehydes are able to be oxidized and ketones cannot be oxidized. There's three common oxidizing agents we'll use for this, and we're going to be going through each of those in turn. If you have a reaction, you have an aldehyde. If you have no reaction, you've clearly got a ketone. The good thing about the oxidizing agents we're going to be covering is that they have a different color between the oxidized and reduced forms. Of course, the other way we could find out the difference between the two is by checking the melting point of the 2,4-DMPH derivative. However, this is quite a long process, so these are quite quick, easy chemical tests. The first test is to use acidified potassium dichromate. Potassium dichromate is orange, and in its reduced form, after it's oxidized our aldehyde, it changes to green. You need this in warm conditions with sulfuric acid to make it work. The disadvantage of this reaction is that it also works on alcohols, so you need to be sure that you've got a ketone or aldehyde first. And that's true of all of the reactions we're going to be covering today. Second one is to use Fehling solution, and that involves using Fehling solution contains copper 2 ions with an alkaline potassium tartrate. You don't need to know what that is. Warm it to 60 degrees, and it will go from this dark blue to this red colour as you get a red precipitate. Final and most important is Tollen's reagent. In Tollen's reagent you have silver 1 ions in excess ammonia. You prepare that yourself by adding silver to ammonia, or first dissolving silver in water, silver 1 in water, and then adding ammonia. You warm it to 60 degrees to get this, and if you do it right, you'll get silver metal precipitated, and it will form a silver mirror around the test tube looking like this. If you do it wrong, or not quite so well, you'll get a black precipitate. Either way, you've got an aldehyde and not a ketone if this happens. So why does this work? Well, Tollen's reaction is a redox reaction, and in order for our aldehyde to be oxidized, the silver must accept an electron and be reduced to make silver metal. That's what gives us silver mirror. So these are the equation for the reactions. So the aldehyde is being oxidized to form a carboxylic acid and it's giving up an electron. The silver is accepting an electron, silver 1 is accepting an electron, become a silver mirror. And this is the full reaction down here. Our aldehyde added to our Tollen's reagent. You do not need to know the formula for this. You just need to know it's silver 1 ions and ammonia going to make silver metal, an ammonium salt, water, and we're losing 3 ammonias. Okay. I hope you found these videos useful Year 12, and we shall continue those as we carry on into carboxylic acids. Thanks very much.